A geometric sequence is a sequence where the next term is determined by multiplying by a common number. This is called the common ratio. So in math, ratio means divide. So a geometric sequence would look like 2, 4, 8, 16, etc. This is geometric because you are multiplying by the same number every time to get the next number. In this case, the number is 2, so this is called your common ratio. Another way you can find your common ratio is taking the second term and dividing it by the first term. So 4 divided by 2 is 2. You could also do the third term divided by the second term, that's 2. So in this case, the common ratio is 2. The explicit formula for a geometric sequence is a sub n. So to find the nth term, you're going to take your first term, which is a sub 1, multiply it by the common ratio taken to the n minus 1 power. So this whole n minus 1 is an exponent. The r I put in parentheses because if r is negative and your exponent is positive, it's going to make a difference. So I just put r in parentheses. Recursive formula is going to be 2 lines again. A sub 1 equals a sub 1, so we need that first term, and then to get the nth term, you're going to take your previous term, which we write as a sub n minus 1, and we're going to multiply it by r, which is the common ratio. So when you have these formulas, what you need to plug in into both of these are your a sub 1 and your r. Okay, everything else stays the same. Just like we found the arithmetic mean, you find the geometric mean of two numbers, so the middle of the two numbers right here. What you're going to do is if this is a and this is b, you're going to take the square root of a times b. So in a geometric sequence, I'll zoom in right here. If I have the sequence 1, 2, and I know it's geometric in these 3 blanks, this number can be found by taking the square root of 1 times 16. So this number is 4. However, if you find the geometric mean of these two, this is the square root of 4, which is 2, and this is the square root of 64, which is 8, these numbers could technically be positive or negative, because you don't know if the common ratio is positive or negative. So it could go positive, 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 or it could go positive, negative, positive, negative, positive. So that's why I need to put that plus or minus. For the second example, I'm going to have these two be negative. This number in between, the square root of negative 1 times negative 16, is negative 4. Or this number has to be a negative, because the sequence is either going to go negative, positive, negative, positive, negative, or it's going to go negative, 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 negative. So in that case, still the two numbers in between need to be positive or negative. So we're going to practice this right here. So number 1, identify whether the sequence is arithmetic, geometric, or neither. If it's geometric, identify the common ratio. So I could see that if I divide negative 216 by 36, 36 divided by negative 6, negative 6 divided by 1, it's going to be the same number. So in that case is geometric, and my r is negative 6. For the second one, if I divide, I don't get the same number, but I can tell that I'm adding 2. So in that case, it's arithmetic. The third one, I am multiplying by negative 4, because if I take negative 384 divided by 96, I get negative 4. 96 divided by negative 24, I get negative 4. Negative 24 divided by 6, I get negative 4. So it's geometric, and r is negative 4. And then the last one, I'm not adding the same number every time, and I divide these, and I don't get the same number, so this is neither. Number 5, a family purchased a house for $150,000. 2 years later, the house was valued, at $188,160. If the value of the home is increasing geometrically, how much was the home worth after 1 year? So in this case, you have a house that's worth $150,000, and 2 years later, you have a house that's worth $188,160. So it's increasing geometrically. So we don't know what it is after 1 year. So this is what it is after 1 year, after 2 years. So what you're going to do is find the geometric mean. So to find the geometric mean, you take the square root of 150,000 times 188,160, and I get $168,000. Okay, number 6, 7, and 8. Find the geometric mean of these. So remember, you take the square root of 20 times 80, and I get 40. But this could be a positive or negative number, because the sequence could go positive, negative, positive, or it could go positive, positive, positive. Second one, I'm going to take the square root of 3 times 18.57, and this is the square root of 55.71. And when I take the square root of that number, I get an irrational number. So this is going to be plus or minus. I'm just going to leave it like that. And then the last one, I'm going to multiply these two and take the square root. So I get plus or minus 378. So because these all started as positives, I have to put plus or minus. And actually, if this was a negative and this was a negative, you could put plus or minus. Okay, number 9. Find the 19th term of the sequence. So first we got to figure out what type of a sequence it is in order to write the formula for it. So if I'm looking at this sequence, I am multiplying by 3 to get the next number. So since I'm multiplying, it's geometric. So the geometric explicit formula is a sub n equals a sub 1 times r to the n minus 1 power. So I need to fill in my a sub 1 and my r. So my a sub n equals, my a sub 1 is my first term, which is 11, and my r is going to be the common ratio. So to find the common ratio, you take the second term and divide it by the first term. So my r is 3, and this is going to be to the n minus 1 power. So to find the 19th term, you're going to plug in 19 for n. So when I plug in 19 for n, just make sure that you're careful when you're putting this in your calculator. I would actually just write this as the 18th power. So it's 11 times 3 to the 18th power, which is 387420489. So it's 30, oops, I put the comma in the wrong spot. So it's 387,420,489. Okay, number 10, find the 19th term again. So this time, it's arithmetic. It's going down by 3 every time. Okay? So my explicit formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. So I need to plug in my a sub 1 and my d. So it's going to be a sub n equals 20 plus n minus 1 times negative 3. Now I'm putting negative 3 in parentheses so it doesn't look like I'm subtracting 3. So to find the 19th term, a sub 19, you're going to plug in 19 for n. 20 plus 19 minus 1 times negative 3. So you can plug that right into your calculator and you get negative 34. So the 19th term is negative 34. Okay, number 11. We're going to write the explicit formula and the recursive formula and find the term of the sequence. So this a sub 1 is 4 To find the common ratio, you do the second term, which is 1, divided by the first term, which is 4. So r is 1/4. So to write the explicit formula, it's going to be a sub n equals a sub 1, which is 4, times your r, so I always put r in parentheses, to the n minus 1 power. That's the explicit formula. The recursive formula is let your first term, it's going to be 2 lines. So a sub 1 equals the first term, which we know is 4. And then a sub n equals the previous term, which is a sub n minus 1, times 1/4. So when you try to find the 8th term of the sequence, I would use the explicit formula, okay? Otherwise, if you do the recursive formula, you have to find the 7th term. You have to keep going. So to find the 8th term of the sequence, I'm going to use my explicit formula. So a sub 8 equals 4 times 1/4 to the 8 minus 1, which is 7. So I put this in my calculator, and what you want to do is, since these numbers are written as fractions, you want to answer as a fraction. So your answer, your calculator will put it as a decimal, change it to a fraction by going to math fraction. So it's 1/4096. Okay, and the number 12, your first term is -2. Your r is the second term divided by the first term, so that's -1. So your explicit formula is going to be, to find the nth term, you're going to take your first term, which is -2. I always put r in parentheses, and then n minus 1. So the recursive formula is going to be 2 lines again. A sub 1, subscript 1, equals -2. A subscript n equals a subscript n minus 1 times -1. And then to find the 80th term, definitely going to want to use the explicit formula. So it's going to be a sub 80, because that stands for the 80th term, equals -2, parentheses, -1 to the 80 minus 1. That's going to be 79. So when you put this in your calculator, you're going to get 2. So the 80th term is 2.